ladies and gentlemen.
So let's talk literal equations. That might sound a little bit weird as a topic, but you can essentially think of it as manipulating formulas, or equations in which we have both constants and variables represented by letters. So you can think of like E equals mc squared as an example, where E and m are variables, but c, the constant for the speed of light, is a constant. It's unchanging. So we might be asked to manipulate equations, or we might be just asked to substitute in values for, the letters that we're given. So let's get started. So first and foremost, we have if d is equal to 1/2 a times t squared, solve for t. So when we solve for something, when we have multiple variables, it means that we are getting that variable alone on one side of the equation, and everything else is going to be on the other, and we have no instances of the variable we're solving for on the other side, meaning there's only one t, and it's all alone on its own side. So if we have this, the first thing I see is the 1/2. So what I'm going to do is I'm going to multiply both sides by 2. That'll cancel with 1/2, giving me 2d is equal to a times t squared. We can get rid of the a by dividing. So if I divide by a, I get d over a, or 2d over a, is equal to t squared. And how do I get the t alone? I square root. So doing that to both sides, I get t is equal to the square root of 2d over a. Now remember, because we introduced the square root, we're going to put a plus or minus. Now, depending on if your formula is talking about a real life like phenomena or not, might determine maybe we don't need the plus or minus. For example, if I'm talking about time, in which we are launching an object or an object is falling, I probably wouldn't include negative time. But because we don't have a situation for this specific literal equation, I'm going to put the plus and minus. So there we go. So questions 2 and 3 refer to an actual situation. And the situation being talked about is a population of bacteria, which is given by an equation p equals 270 plus 2.1t, where p is the population of bacteria, and it's dependent upon time in hours. We can see that where p is solved for, and t is part of the equation. That's what it means to be dependent on. So question 2 is asking us to write an equation to represent time dependent upon the population of bacteria, which means that where p is solved for here and t is within the equation, it's asking us to switch, where t is all alone, and it's dependent upon a population which we could plug in. So we're going to solve for the t in this equation. So first thing I'm going to do is I'm going to rewrite. So we have p is equal to 270 plus 2.1t. So to solve it, we are going to subtract 270 from both sides, leaving us with p minus 270 is equal to 2.1t, and then we can divide everything by 2.1. Now, you could distribute this 2.1, but you really don't need to. It doesn't specify that we have to, so p minus 270 over 2.1 is all we really need. Now, if this was a multiple choice question and they did distribute it, you could identify that, but if it's just asking us for what an equation we could use, this is good enough. Now we can actually use this. Question 3 asks us how many hours does it take for the population of bacteria to exceed 320? Well, it doesn't make sense to use the original formula because we would have to do all of the algebra that we already did in order to solve for t. So instead, we can use the already solved for t equation and then plug in 320 for the population. So 320 take away 270 over 2.1 is equal to t. Well, 320 minus 270 would be 50. And then 50 divided by 2.1 is what we're looking for. So in order to figure this out, we can always use a calculator. So 50 divided by 2.1 gets us 23.8095. And that goes on for quite a bit. So remember, we're talking about an actual situation here. We're going to round up. How many hours does it take for the population to exceed 320? It's going to take 24 hours. It doesn't make sense to say 23 because then we wouldn't have enough. We would have under the 320, so we need to round up in this case. So it doesn't really matter that it's 0.8. If it was 0.1, we would still round up because the situation calls for that. So just keep that in mind. Keep in mind your situation, and that'll help a little bit with the rounding if you need to do so. If you have any questions about this, please let me know. Otherwise, I'll see you in the next video.